Well, welcome. My name is Breitner. I'm part of Dell Technologies. I actually belong to the storage solutions team in Dell Tech. And I want to talk a little bit about what's going on with data center consolidation and the need for edge clouds, or edge computing if you like to think about it that way. So first thing is, what is the edge? Is it something like this? I don't think so. I think of the edge as the place where we're interacting with the digital world. And there actually is a definition about what edge is about. And it is the physical location where you interact with the networked digital world. And it's important that it be networked as well as digital. So one of the things that companies have done in order to support their employees, their contractors, their customers, is set up data centers, and these data centers proliferate around the world. They put them where they make sense for what that company's needs are. And they just multiply. There may be large ones, there may be small ones. They might actually just be a server in a closet in the back of an office, but it's still a data center. Some are unmanaged, some are fully managed. As processing power got more and more powerful, and as networks became more reliable and had higher bandwidth, all of these data centers started to consolidate down to a smaller number of much, much larger data centers. These data centers have enormous compute capacity, they have storage, they've got networking. The challenge then comes is that as people started to consolidate the data centers, these remote locations where users were actually consuming resources no longer have anything there. They're actually moved over into the data center. Now that may or may not be a problem, and we'll talk about that as we go through. And at about the same time this data center consolidation activity occurred, we ended up with public clouds coming along. And we ended up with hyperscalers like AWS and Azure and Google and so on. And they built out data centers in various locations as well. Their ones were intended to service their customers that wanted to consume compute on demand and pay for it as they consumed it. Distinctly different from the way things are consumed in a data center, but it's the same idea. Now, one thing that happened with these hyperscaler clouds is that they centralize what goes on, they standardize on the equipment, and they automate everything. That's the power that comes from these cloud vendors. You can apply the same principles to the data center, and if you actually wander around the expo show floor here, you'll find people that are talking about doing exactly that. But let's get back to where we started. We're talking about the edge. And most people, when they think of the edge, they think about my laptop, my cell phone, I'm in a Starbucks or a coffee house, or I'm wandering around somewhere, I need to access compute resources. I'm going to stop here a minute and simply go and look at, well, VMware has a vision of what's going to happen in the future, and that is any device running any application on any cloud. And then what I want to focus on is these tiny little clouds just here. They're edge clouds. And even though they're tagged as very small, they're actually very important, and they're going to be growing bigger and bigger and bigger as time goes by. So when people think about, well, what's it look like if I actually have an edge cloud or an edge data center, it looks something like this, is what people think of. Well, that's all well and good, but these things don't scale all over the place they need to be, nor do the hyperscaler clouds. They're not everywhere that you necessarily need them. They're in important locations, but not everywhere they are needed. So back to the definition. Physical location where things and people interact with the network digital world. Well, there's one important word here, things. And that's the thing that's changing, or that's what's going to be changing what people think about with edge clouds and edge computing. And it's the Internet of Things. We have this proliferation of devices. They're very small, they're all over the place. They could be security cameras, they might be the security system for your house that allows you to open and close the door remotely. It might be sensors in your car that's telling your service center that, hey, this car's going to need to come in, you better figure out some way to let the owner know. we end up with all of these different devices floating around. And these devices need to be serviced in some way, shape or form. And if you actually look at what the analysts are saying, they're saying with the Internet of Things coming along, you need to move the compute closer to where these devices are, where these things can be delivered, where they can deliver the value to the end users involved. Now, the example I keep on thinking of, you can actually put remote small compute platforms out where you need them, but they don't necessarily have the power and the storage required for what's going on. And if you actually have self-driving cars, you have to make a decision in milliseconds if something occurs. If something untoward hops in front of the car, I don't know what it is, a deer, a person, a telegraph pole, you need to make a decision within milliseconds about what to do. Put the brakes on, stop. When someone's walking out to a front door and you want to unlock the door, well, milliseconds don't matter so much. Seconds probably matter in that case. So it varies from case to case. But the point here is that you need to have access to those compute resources to make the decisions that need to be done to actually make a change in what's going on. Some need to happen very, very quickly. Some can take a little longer. The quicker you need to make the decision, the more compute power you need to have available locally to deal with that. And that's where we get to this new paradigm of what does an architecture look like when we actually have to worry about edge computing. So we end up with, we still have our clouds, we still have our data centers, they're still providing service that's needed, but then out at the edge, out where these devices are located or very close to those devices, you actually need to have a different architecture, a compute platform, some storage, networking in order to deliver what needs to be done for those remote devices that need to take action at that time. Some of these things can be a little later in the time frame, but they have to be done. And these devices, they're not just a couple of them, they're not hundreds, they're not thousands, they're not even tens of thousands, they're millions of these devices out there. And this environment is growing rapidly day by day. The estimates right now are that 44 zettabytes of data will be produced by 2020. So we're like 4 months away. There's going to be 44 zettabytes of data. We're producing data at the rate of 1.7 megabytes per person per second. It's huge amounts of data that are coming in. You hear this from all around, but where's it coming from? Why is it coming? It's coming because we've got all of these little devices that are actually generating signals back to somewhere saying everything's okay or everything's not okay. And it's not just collecting the data sets that are coming in there. The frequency at which these data items arrive can also matter. So you may actually look at a jet engine, for example. It's always pinging back to home base, which is usually somewhere in the airline's main base. Doesn't matter where the aircraft is in the world. It's pinging back, it's saying everything's okay, everything's okay. But there's multiple sensors in a jet engine. There's probably something like 2,000 in a jet engine, always coming back every second with some sort of information. If you need to take action on that, you need to actually be able to get back to the pilot of the plane saying, something unusual occurred. But after that's been taken care of, the maintenance people want to say, well, hang on, what exactly happened there? I know what broke, I know what we did to fix it, but was there something there that would help me figure out why it broke? And that's when you look at the frequency at which these data sets arrive, you can actually look at it and say, oh, it started to come in more and more frequent for this particular device. That's a trigger point to say there's a failure occurring, perhaps. But the whole idea here is that it's not only collecting the data sets and taking action, it's also preserving those for other analysis, and that's why the connection back to the cloud and the data center is also important. So what I see moving forward is data centers still in place, cloud vendors having cloud things available for people to consume, but what about if I want to do something that isn't handled by my large data centers or by the clouds that I choose? So I've got two examples I want to talk about, and because I'm from Dell, I want to talk about Dell stuff. So the first one here is I can actually run a software-defined storage platform in the cloud. In this particular instance, it's being used to support virtual desktops, where people need to actually have access to either corporate data that's back in the data center, or they're generating new data that also needs to be put back into the data center for preservation. So what we have here is a software-defined storage platform running in VMC on AWS, talking back to the data center. It's a bidirectional transfer, making sure that the data that people need is available for them to use. And the last part is that not all the data needs to be accessed all the time. So I can actually tier the less used data off to something like an S3 bucket. It can be brought back when needed, but it's there where the users are located, where they can actually consume it. And then the last thing about this is, so what if I don't have a cloud provider's point of presence anywhere nearby? What can I do? Well, I could actually go deploy my own private cloud in that location. And that allows me to actually get the benefits of cloud, produce edge computing out near where it needs to be, consumed by those devices that need to consume it. And I can grow this thing if I need to, if there's insufficient resources. And so what I see the future coming along is this mixture of data centers, cloud locations, and these private clouds being deployed for consumption by these Internet of Things devices and the people that are actually making use of the results from that. So I'm at time. If you are interested in any more information about this, drop by booth 1027, where you can actually talk to people about this. And I will be around. Actually, I won't be around because I actually have to go to another session in a few minutes, but I can actually take questions offline before I go. Thank you very much.